Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. Today, the topic that we are going to discuss is vertically opposite angles. Vertical in this case mean they share the same vertex, that is the corner point, not the usual meaning of up-down. Okay, the interesting thing here is that vertical opposite angles are always equal. In fact, they are congruent angles. So let us see what is vertically opposite angles first. When two lines intersect each other, four angles are formed. The pair of angles which lie on the opposite sides of the point of intersection are called vertically opposite angle. In the given figure, two straight lines AB and CD intersect each other at the point O. Angle AOD and BOC form one pair of vertically opposite angles, the blue angles, whereas the angles AOC and BOD form another pair of vertically opposite angles. You should know that vertically opposite angles are always equal. So that is, you can write it as, hope this makes sense to you. For example, in the given figure, two lines WX and YZ are intersecting at a point O. We observe that with the intersection of these lines, four angles have been formed. Angles 1, 3 form a pair of vertically opposite angles, while the angles 2 and 4 form another pair of vertically opposite angles. And you can say that clearly angles 1 and 2 form a linear pair. Am I right? Because these two angles lie on a same straight line. The linear pairs add up to give 180 degrees because the linear pairs are supplementary. Am I right? So let me write an equation using this concept. If you subtract angle 2 from both these sides, we'll be getting, let this be equation number 1. Please look at the figure. We can find another pair of linear pair. So similarly, you can say that angle 2 and angle 3 form a linear pair. So you could write an equation in the same way because linear pairs are always supplementary. That is, they add up to give 180 degrees. You can rewrite this one. I'm just going to subtract angle 2 from both these sides. So I'll get an angle for angle 3. Let this be equation number 2. Please observe equation 1 and 2. We will get the right hand side of the equations of equation 1 and 2 are same. So you can equate the left hand side of the equations. Angle 1 is equal to angle 3. We are just using the substitution property here. Again, by looking at the figure, you can say that angle 2 is equal to angle 4. You can prove in the same way that we proved angle 1 equal to angle 3. Hence, we have proved if two lines intersect, then vertically opposite angles are always equal. Let me add one more information. Please look at the figure on the board. Angle 1 and angle 2 are not vertically opposite angles because their arms do not form two pairs of opposite rays. Am I right? Hope you understand the difference between the previous figure and this one. So, vertically opposite angles should be formed by two pairs of opposite rays. Only then the angles will be equal. Okay, now let us solve various examples on vertically opposite angles. Here is an example. In the given figure, find the measure of unknown angles. Okay, let us start with the solution. Please observe the figure given. Angle 3 and 60 degree is vertical. Am I right? We have two lines. I have just highlighted the opposite rays. Angle 3 and angle 60 are vertically opposite angles. Same way, angle 2 is vertical to this 90 degree. Let me highlight that too. Please look at the figure. We have two rays. Angle 2 and 90 degree are vertical opposite angles. So you can say that angle 2 is equal to 90 degrees and angle 3 is equal to 60 degrees because of the property vertically opposite angles. Please look at the figure. This is a straight line. And angle 2, angle 1 and 60 are the three angles on a straight line. We know that no matter how many angles are there on a straight line, if you just add up all those angles, you will be getting 180 degrees because that is the property of a straight line. It is just the half of the full angle. So it should be equal to 180 degrees. So if you add angle 2, angle 1 and 60, you should be getting 180 degrees. You can just replace angle 2 by 90. Add 90 and 60. That will give you 150. Just subtract 150 from both the sides to get the value of angle 1. We got the value for angle 1. Angle 3 is 60, angle 2 is 90, angle 1 is 30 degrees. Now let's find the leftover angle on the figure. Angle 5 is 90 degree. It is directly given in the figure. We should find angle 4 now. Please note that these two are opposite rays and they are intersecting with each other, and you can say that angle 1 and 4 are vertically opposite angles. So therefore angle 4 is equal to angle 1, which is equal to 30 degrees. We just got the answer. So equate 4 equal to 30 degree. Hence we have found all the unknown angles in the given figure. Hope you are clear with this example. Let me take next example. Here is your next example. In the given figure there are lines PQ, RS and TV that intersect at the point O. If the ratio x is to y is to z is 1 is to 2 is to 3, then find the values of x, y, z. Okay, this is an interesting example. Here we are going to use the concept full angle. That is, the sum of all the angles at a point is equal to 360 degrees. Am I right? From the figure you can say that POR and SOQ equal to x degrees, because pair of vertically opposite angles are equal. Same way VOQ and POT. Okay, let me highlight it on the board. Angle VOQ and POT is equal to y degrees, because pair of vertically opposite angles are equal. Let's use the same concept and identify another pair. TOS and ROV equal to z degrees, because pair of vertically opposite angles are equal. Now you can say that POT, POR and ROV plus VOQ, QOS or SOQ, both are same, and SOT. If you just add all these six, and you'll be getting 360 degrees. Okay, let me write it as an equation. Just add all these 6 and set that equal to 360 degrees. Now use the angles. So x, y, z, x, y, z equal to 360 degrees. Now let me combine all the like terms. We have 2x, 2y and 2z. So this could be rewritten as, let me take the common factor outside. We have 3 terms on the left side of the equation and all the terms have coefficient 2. So I'm just going to take it out as a common factor out and write all the leftovers within a parenthesis. Divide both the sides by 2. 360 over 2 will give you 180 degrees. So I'm setting this equation as equation number 1. Let the common ratio be A. In this question it is given as 1 is to 2 is to 3. So you can set up this as x equal to a, y equal to 2a and z equal to 3a. You can just use this a, 2a, 3a in equation number 1 and solve for the variable a. Replace x by a, replace y by 2a and replace z by 3a. Add all the like terms on the left hand side. 1 plus 2 plus 3 will give you 6. Same way a plus 2a plus 3a will give you 6a. Divide both the sides by 6. So you'll be getting x equal to a. Therefore it means x is equal to 30 degrees. Y equal to 2a. Replace a by 30. 2 times 30 will give you 60 degrees. 3 times 30 will give you 90 degrees. Therefore the measures of the angles are 30 degrees, 60 degree and 90 degrees. Hope you are clear with this example. So when the given data is in the form of ratio, you can set up a variable for that one and use all the properties that is possible. Here I have used the vertically opposite angles and sum of the angles on a straight line is equal to 180 degrees. Hope this makes sense to you. Many times when you think of opposites, you think of things that are different. In this lesson, we learned that when you look at opposite angles and find out that not all opposites are different. Most importantly, you learned that opposite angles are congruent angles. Congruent means equal to, the same, meaning they have the same angle degrees. To repeat, angles that are opposite have the same angle measurements. Angles that are opposite have the same angle measurements. When two lines cross, not only do they create two sets of opposite angles, but the added total of the two opposite sets of angles make a circle. Remember that a circle is equal to 360 degrees. So the sum of the angles will give you 360 degrees. Because two pairs of opposite angles make a circle that measures 360 degrees, you can find the measure of the three angles when given only one angle measurement. Vertically opposite angle problems are going to be really interesting, and it will be easier for you to identify the missing angles when the topic comes under vertically opposite angles. Hope you are clear with the examples and the concept that we discussed in today's video. See you in the next video with an